This is Chapter 14 lecture, Handling Errors. This is a very long deck, so we'll probably split this into 3 separate lectures to make it more digestible for you and give you an opportunity to work through things. Take some time, go through this stuff. These are different concepts than what we've handled elsewhere in the class, so you're definitely going to have more information than what you're necessarily used to. There's a lot of good stuff in here, and any seasoned developer will use this stuff to their advantage, and if you do it properly, life works out better. All right, main concepts to be covered is defensive programming, anticipating that things could go wrong. This is kind of a Murphy's Law thing. If it can go wrong, it will go wrong. And if you have proper error handling, you can actually keep from that. As you guys get through your Java development career, you're going to start seeing error logs and system logs, and it's amazing how many errors get thrown in a Java application all the time because people have done bad jobs at error handling, or what's worse is something called burying an error, which is where they actually catch it and just ignore it and move on because they didn't code for that eventuality. These are things that should be avoided. They are not best practices. You want to catch all your errors, you want to handle all your errors, and you want to gracefully exit, not throw a stack dump is what it's called, if at all possible. Error reporting and simple file processing are things that we're going to go through. Typical error situations: incorrect implementation, does not meet the specification, inappropriate object request, you exceeded the bounds of an index, inconsistent or inappropriate object state. Basically what happens is you've encountered a situation that you didn't necessarily plan for. Believe it or not, sometimes you actually try on purpose, and you have an error on purpose. One of the great examples would be opening a file as an example, or checking to see if the state of the database is connected. And if it's not connected, then go ahead and establish a connection. So it's not necessarily a bad thing that you get an error, but it is a bad thing when you don't handle the error and handle it gracefully. Not always programmer error. Errors often arise from the environment. For example, you don't control that a disk gets full, or that a user keyed in a wrong URL, or that the network went down, or any of a bunch of different situations that were just simply impossible for you to anticipate, and that's why you put in error handling, is to be able to catch those and be able to provide graceful exits when appropriate. File processing is particular error prone. Missing files, lack of appropriate permissions. I talked about a few of these things earlier. This is where an error that comes up is something that you expect, and sometimes you actually plan for it. There are some cases where you actually will cause an error. Exploring errors through the address book projects. I'll go ahead and give a separate demo on those, just so you have some information, and we'll go from there. 2 aspects that it talks about is error reporting and error handling. So defensive programming. Client-server interaction. Should a server assume that clients are well behaved, or should it assume that clients are potentially hostile? What do you feel? Significant differences in implementation are required depending on your approach. One is assuming that something will go wrong, and one is assuming that nothing will go wrong. As long as you've got error handling, you can blend the two. Issues to be addressed. How much checking by a server on a method call? How to report errors? How can a client anticipate a failure? This is a client as in this client-server model that they talked about. How should a client deal with failure? These are all things that should be designed in early on before you start coding, and should be part of a general philosophy or guiding principles of your Java shop. An example, create an address book object. Try to remove any entry. A runtime error results. Whose fault is this? You tell me. Anticipation and prevention are preferable to appointing blame or portioning blame. In other words, handle it gracefully. Don't let the system break. Why give a user a bad experience if you don't have to? It should be your goal and the goal of those on your team to provide the best user experience whenever possible and graceful exits when needed. Argument values. Arguments represent a major vulnerability for a server object. Constructor arguments initialize state. Method arguments often contribute to behavior. Argument checking is one defensive measure. So in other words, you go through and you make sure that the data types that are coming in are correct. and you go from there. But ultimately, if someone finds a way to call your object incorrectly, you want a way to be able to gracefully handle this and get out of it. Checking the key. So here's an example: is if key in use, this would be key, then you want to go ahead and check this information. It's a simple example, probably too simple for this case, but in this case, before you do it, you make sure. So this way, when you go into the collection to remove this, let's say that this is a hash set, you don't try to delete something that doesn't exist and generate an error that wasn't needed. Server error reporting. How to report illegal arguments. To the user, is there human error? Can they solve the problem? To the client object, return a diagnostic value. You've heard me throughout this class talk about returning a -1 on a fail and a 0 on a success. This is something that I would strongly encourage you to do with diagnostic values if you're handling the error. Sometimes you want to catch an error and pass it back, so you're going to throw an exception. That's a Java term. In terms of this, I would argue if it's an illegal argument, meaning that they keyed in illegal information, yes, you want to do some type of notification to them. But if it's a code issue, you should handle it internally and prevent the user from a negative experience. It is really frustrating for a user to get what they will call gobbledygook or computer gibberish or things like that on the screen when they're trying to use a system you've architected. Returning a diagnostic. In this case, if it was successful, return a true. If it wasn't successful, return a false. I again also do 0 for success, -1 for fail, 1 for success, -1 for fail. It depends on what your shop's logic is. This approach is also equally fine. Just think about it and make sure that you guys have consistent implementation. Client can check for success. If contacts.remove details, so in other words, if it succeeded, do this. If it failed, do something else. And that's based on this true and false coming through. Okay? Potential client responses. Test the return value, attempt recovery, avoid program failure, ignore the return value, etc. Ignore is probably the one that's the least acceptable. And is done sometimes. You sometimes just capture the return value for debugging purposes and nothing more. Exceptions are preferable though. Exception throwing principles. A special language feature, no special return value needed, errors cannot be ignored in the client, the normal flow of control is interrupted, and specific recovery actions are encouraged. To be clear, you can use exception handling, but returning success and fails is a very good idea as a rule. Throwing an exception. Alright, so we're going to add this to our repertoire of knowledge. Sample code at the top, this is all JavaDoc. Contact details, if the key equals no, then we're going to throw a new, this is a new object, illegal argument exception. So illegal argument exception is a type of error object. And the message that we're going to say is null key in get details. So now what's going to happen is this is going to break. Whoever was calling it is going to be notified that this just broke. They need to have a try catch, and you go from there. There's a couple other things that we'll talk about later, but this is pretty much it. Notice the one JavaDoc addition that we have now. Throwing an exception. An exception object is constructed, new exception type, quotes, blah. What we're doing here, this is the exception type. The exception object is thrown, that's the throw, and then Java documentation. If you're properly documenting your code, you've done that. Okay? So let's go ahead and look at the class hierarchy. Throwable, error, exception, runtime exception, myChecked exception, etc. These are what you've added. This is what Java comes with. Okay? And there's a ton of exceptions that you can use. Exception categories. Checked exceptions are a subclass of exceptions. Use for anticipated failures where recovery may be possible. So they're saying throw this when you think you can be able to recover, and you're going to check for it. Unchecked exceptions are a subclass of runtime exception and used for unanticipated failures and where recovery is unlikely. So expected things, you want to inherit from that. Unexpected from here. and then it's up to you to take it from there. With that, I'm going to go ahead and pause this presentation, start up another version of it or another section, part 2. Hopefully you've got something out of this portion of the lecture. There's a lot of information in Chapter 14. Additional information is available online. Please spend the time going through both of them. I'll talk to you in a few minutes in part 2.